And with that, I'm very pleased to introduce our first speaker, my colleague, Darla Bodnarchuk at Krux and IMDEX. And Darla is the CTO for Krux. Thanks, Darla.
Hello, everyone. So, just going to flip through here to the start of my slides. I'll let our new friend sit down before I get started. Thank you, everyone, for coming. So today I'm going to be talking about the digital drill site. And so I'm going to tell you why this matters, what the digital drill site means today and the advantages that we're getting from digitization, and then what this looks like in the future. So, some of the data that we have from McKinsey shows that there's a lot of opportunity. The $100 million number that we see on the slide is just, their extremely conservative estimate. The efficiencies that we can find in mining optimization, or they estimate, up to the billions. So there's a lot of room to use data to make us better. So this is an opportunity for all of us. It's not just one side or the other that can get an advantage from the data at the digital drill site. Mining companies can get more meters for their investment. Drillers obviously want to be drilling productively and getting paid for it, not being on standby. And so if we can have better data, we can have less waste, and it creates a shared opportunity for all of us to be more successful. So digging a little bit more into why the digital drill site data matters and the challenges we face in the industries, like the first two slides talked about, there is an efficiency. So obviously saving money is great, but it's more than that. We have drillers already generating very powerful data, but are we using it in ways that actually help us do our jobs better? Innovation between drilling and mining companies and service providers. Sometimes we all have great ideas, but it can be disconnected. So how can we use the data as a through line to connect all those pieces together? We also have the challenges of, it's still people on our sites that drill, and the technology is changing that, but as we have younger drillers coming in, there's challenges. They don't have the experience of guys that have been in the field for 40 years. And then lastly, mining is changing itself. The energy transition is asking more of us, and we have to, pick up to be able to meet those needs. So this is really talking about what does digitization mean today and why is this an advantage? So first of all, standardization. For us to get true value from the data across sites, across drills, our data has to talk the same language. So this can be things as simple as when I talk about what activities was my drill doing, was I pulling rod or tripping rod? And as much as that seems not a big deal as a human interpreting that data, when you try to put that through the computer, it's not as easy. So that's a very simplistic example, but in a lot of ways, there's so much power in just some basic standardization. And then next step, when I have my data in a digitized form that it's coming in instantly to the system, I can get a lot more basic basic visualization and transparency, but when I get that instantly and I can go look at that the same day that the drilling is happening, it provides a lot of value for me to be able to operate and gather insight from what's happening on my site. So once I have that data coming in, like I said, you can then accelerate your operations. You can make better decisions faster. And looking at that data over time, beyond just like the obvious day-to-day optimizations, we can get then deeper optimizations. We can look at trends over time. We can look at trends over sites and see how we can actually truly optimize our performance. And then lastly, once we have this data in this standardized, consistent, high-quality way, how do we move this across systems? How many systems do you enter the hole color information into? How many times does it get entered exactly the same in all those systems? So being able to take this data from one system to the next and truly creating an integrated workflow is very important and very powerful. So next I'm going to move into, this is just kind of talking about what is digitization, what are the advantages at a high level, but some real examples of why this matters. So this is just a quote from one of our clients that they see real benefit, you know, in improving their drilling, but it's really about how they can then better serve their client. They can be a better strategic partner, and they can really change the return on investment in the drilling. So I have a few slides here from a case study we did, and the first couple are really just about the initial optimization from getting the digitized data from a drill rig. So you can see on these charts that, or maybe you can't, the writing is very tiny. The brown line that is trending down is cost per meter, and the blue line that is trending up is meters per shift. And so obviously I'm getting more drilling, I'm spending less money. That's a win-win. So you can see in this chart that it took several quarters. So this is the first site, site A. It took them a year, maybe a little bit more than a year, to really get the advantages from implementing this system and understand where are the inefficiencies. How can we change our operations to make our drilling better, to be able to drill more with the money that we have. And so some of the things they found was reducing standby. They were able to find inconsistencies across different contractors. This program overall, I believe, had 4 contractors, 28 rigs. So it was a lot to manage, and there's a lot of moving pieces if all you have is, you know, paper or Excel reports, and you have to bring that all together manually. So this was the first site. Moving off to the second site, this was implemented first. So when they implemented the system on site B, the second site, they were able to see those improvements after only 2 quarters. It took them, you know, a matter of weeks to take their lessons learned, look at the data that was coming in for the new site, and really implement those to get the benefit right away. So on the operational side, you definitely can get immediate tangible results. The next thing I want to talk about is not just operating a drilling program, but also the geology. So we have a few examples of holes. So they exported the data out of Krux, and they actually imported it into Leapfrog. So you can see 3 different holes that we're highlighting there. And on these charts, the color along the hole is rate of penetration of drilling. And so red being the fastest, and then going down to blue being the slowest rate of penetration. And so this is manually collected data. It is digitized, but it is still collected from the driller. And so it's an average rate of penetration. So that means I said perhaps I drilled from 50 to 100 meters and it took me an hour, and it gives me an average rate of penetration over that range. So while it's meaningful data, it's not super granular data. And so what we found especially interesting about this, when I'm looking, so this is the example of hole 1. Each of these 3 holes, we were able to compare the data and see that it matched up with different things that we're seeing in the geology. So this one, you can see the fault zone. So it's about a 10-meter fault zone. And so as soon as they hit that fault zone, you can see that the drilling accelerates into orange and red in terms of rate of penetration. So as soon as they went through that fault zone, the drill just pushed right through. Our second hole. So the second hole, what we're looking at here, so they're drilling through highly silicified ground. And while I don't have every detail of what every different rate of penetration mean, the geologist went over this with us and is saying this is very representative when we actually have the assay grades of what happened. And looking at this rate of penetration, it does make sense. It lines up with my expectations of what we found from the core. And then our third hole. So what we're looking at here is talking about about rock hardness and how that affects rate of penetration. So our geologist was a bit surprised when she first saw that, but then thinking about the rock hardness, the faster zone right at the top of rate of penetration is a highly brecciated rock. And then after that, you get into andesite. So it does impact, and you can see where those differences happen in the rock. And so the geologists we worked on this with, as I said before, this is average data. So to truly, derive insights from this without having the other data to back it up is not quite there. She did tell us, like, she wouldn't use this to build models. It wouldn't be a proxy for logging, but she was very excited. And so we were very excited to see that this actually lines up with her expectations. And so that really ties me into the future. So why is this very exciting? Yes, we love that we can save money and make drilling better, and we help our clients get their drill programs done. But what could this be in the future? Can we actually derive more from this drilling data? Oh, sorry, there was one more slide. Yeah, so that ties into what's next. So right now, like I said, we have the drillers on site. It's digitized and it's high quality and there's validations, but they're still manually entering this data. It's not real time. It's not instantaneous rate of penetration and all the other drilling parameters. So going forward, what we want is that real-time data. So this is a representation of what that data looks like in our system. This is the data coming off the drill rig and all the different parameters and how those tie in. So the charts that we showed before when I went through the 3 holes was all rate of penetration. But there's other interesting parameters that help us understand, like torque, etc., that come off the drill rig that help us understand what's truly happening and then can tie back into, why are we doing this drilling in the first rate? It's to understand the rock, it's to understand the geology, and that data can be part of this picture to help us make better decisions faster. So when we look forward to the drill site of the future, this is the vision with all the pieces. And my colleagues are going to talk more about fluids and various things. So I'm not going to go into details, but this just shows our little Bluetooth symbol everywhere on this slide. Really shows these are all the places that we can pull data out. And then the challenge is, how do we tie these pieces together? How do we feed this back in, not only to make drilling better, but to help us learn about what we're drilling, what's down the hole, because that's the point of why we're here, right? So it's a very exciting future, and there's only more that we can do. And like everything, it will take time, but we see this as very much a shared future. It can't be just Krux, it can't be just IMDEX. It has to be all of our industry partners. It has to be our clients, because there's no like one set of data that solves this problem. There's no one system. We all have many systems that we use, and we have to be able to tie this together and make a cohesive picture. So we truly believe that this is a shared vision with IMDEX across the industry with all of our clients and all of our partners that we can achieve. So my last slide is just talking a little bit about Krux. We are already across the globe. We've drilled 10 million meters. We've managed lots of money, and we are very excited about the future. We're excited to keep doing this. We have a footprint, a lot of places, and we really believe in what the future of data can do in the industry. Thank you.
Thanks, Darla. I like you got very excited, the opportunities there that Krux has with IMDEX. We're all very excited to be joining the IMDEX family at the end of this month.